Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of lines. So as per the problem, for each pair of lines, determine the size of the acute angle to the nearest degree that is created by the intersection of the lines. So let's start with the first pair. In the first pair, the equations are given in vector form. From the vector form equation, we can find the direction vector of the lines. So the direction vector for the first line is 2, -5. It's the vector with the parameter t. That's the direction vector of the first line. In the second equation, the sign of t is negative. As you may remember, in the general equation of a line in vector form, the sign of the t is positive. So I'll write it on the board. So this is the general equation of vector form of line. So we'll have to modify the second equation in the first pair. We'll have to distribute this negative sign into the vector. So we'll multiply both components by a -1 and that will make the t positive. So -4 times -1 is +4 and -1 times -1 is +1. So the direction vector of this line is 4, 1. Now the angle between the lines is equal to the angle between their direction vectors. This is a very important concept we need to understand and memorize. So we'll find the angle between these direction vectors m1 and m2 using the dot product equation. Theta is the angle between these direction vectors. Now we can use the vectors m1 and m2. For the magnitude of the vectors, we should square the components, add them, and apply square root to the sum. Now we can do the dot product on the left side. So we should multiply the x and y components. And on the right side, under the first square root, we get 29 because 2 squared is 4, -5 squared is 25, and 4 plus 25 is 29. And under the second square root, we get 17. Now we can simplify the expression on the left side. Now we can multiply square root of 29 by square root of 17. So on the left side we get 3. Now we can divide both sides by 22.204. And next we have to do the inverse of cos. And now we can evaluate this inverse of cos. So I got almost 82 degrees. So this is the acute angle between the direction vectors, and it is also the acute angle between the lines, because the angle between the direction vectors is equal to the angle between the lines. So this should be the final answer for part A. Now we can analyze the second pair of lines. In the second pair, the equations are given in parametric form. So the first step is to find the direction vector of the two lines. So let's start with the first line. The components of direction vector of a line are the coefficients of t terms in the x and y equations. The x component of the direction vector is -5, and the y component of the direction vector is 4, because that's the coefficient of the t term in the y equation. So this is the direction vector of the first line. Now we can find the direction vector of the second line. The coefficient of t in the x equation is 1. The coefficient of t in the y equation is -6. So this is the direction vector of the second line. Now we can use the dot product equation to find the angle between these direction vectors. Now we can use the vectors. For the magnitudes, we should square the components, add them, and apply square root to the sum. Now we can do the dot product on the left side. So we should multiply the x and y components. And we can simplify the square root terms. -5 square is 25, 4 square is 16, and 25 plus 16 is equal to square root of 41. 1 square is 1, -6 square is 36, and 1 plus 36 is equal to 37. Now we can simplify the expression on the left side. On the right side, we can multiply square root of 41 and square root of 37. So I get 38.949. Now we can divide both sides by 38.949. Now we can do the inverse of cos. Now we can evaluate this inverse of cos. So I got almost 138 degrees. So this is the angle between the direction vectors. And this is also the angle between the lines. Now 138 degrees is an obtuse angle because its measure is between 90 degrees and 180 degrees, and we need to find the acute angle between the lines. And for that we should subtract 138 degrees from 180 degrees, which is equal to 42 degrees. So that means the acute angle between the lines is 42 degrees. So this should be the final answer for the second pair of lines. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.